Hi everyone. Today let's talk about properties of limits. I'm going to give you some properties of the limits and then we will practice some questions. And if you still don't understand, please comment below and I will post more examples and then we will work on it. Suppose limit x approaches a f of x is equal a. And limit x approaches a of g of x is equal m. Like if you guys pay attention closely, this is one function, that's my another one. And this function limit when I approach a is L, and when I approach x approach a for this function, the limit is m. Find each of the following limit in terms of L and m. So these are the properties, okay? Limit x approaches a, f of x plus g of x. If you have something like this, like you have one function plus another function, the two functions are adding, your x is approaching a, then how would you do this? And guys, these properties are really important and it will make your life really easy if you apply them, okay, on the limit questions. So let's try this. If that's the case, then you know limit x approaches a is distributing, it's like a distributing property. Limit x approaches a is distributing with both of these functions, and that's how I'm going to write them. Limit x approaches a of f of x plus limit x approaches a of g of x. So it make it easier, so you are only looking for the limit for the f of x function and then you're going to look for the limit of g of x and you add them together. So since we already know the limit x approaches a for f of x is L, so I'm going to write L here, plus limit x approaches a of g of x is m, and these lm are like y values. Remember, limit is always a y value where the x is approaching. So these are my real values, real numbers. So L plus M, and that will be my answer for that. Okay, let's go this, and this will be the same thing. You're just distributing this limit x approaches a. So I'm gonna go limit x approaches a of f of x minus limit x approaches a of g of x. Now, if you guys pay attention here, again, I'm looking for the limit of f of x and I'm subtracting g of x. So the f of x limit, we already know it's L, the g of x limit is m, and that's how we will get the answer, whatever the answer is. Okay, and make sure that you apply the properties. I'm keep saying this because if you find the limit of these two functions together at the same time and subtracting, it will make it harder. So just apply the properties. Let's go to the division. So division is going to go the same way. Limit x approaches a of f of x over, okay, that's the division, limit x approaches a of g of x. Then the limit of f of x is L, the limit of g of x is m. So that's how you get it. And these are real numbers, so you can divide. Change it into decimal. It should be three decimal places, or maybe it's a whole number, whatever the numbers are. Okay, number 4. This is going to go the same way. Limit x approaches a of f of x times limit x approaches a of g of x. This limit is L times that limit, and whatever the answer you get from this by multiplying. Number 5, if you guys closely pay attention, this is a coefficient, any coefficient in front of the function. Like this one is a coefficient, a real number, but that's a coefficient. Okay, so how do we do this? You don't touch this coefficient, it's going to stay as it is. So let's see this. Limit x approaches a c, okay, times limit x approaches a of f of x. Now, what is the c? Because you know c is a constant. For example, I'm talking about limit x approaches a of 2. The c is a constant. It's 2. So what is the limit when you approach 2? It means it's going to be that 2. You can't do anything with that one, okay? So the constant limit is always that constant times the f of x limit was L. So you have C and L, so you multiply these numbers and you will get the answer. Remember, constant limit is always constant itself, is always constant itself. Okay? This is important that you know that. Okay. Now, this one, how do we do this? Limit x approaches f of x to the whole power of p. So it's going to go the same way. Limit x approaches a of f of x. And this whole thing has that exponent on the top. So limit x approaches a of f of x, it was L. So you have a L to the power p. Okay, and I already explained that the limit of any constant is that constant. So what is the limit of this? The limit of x approaches a to c is c. Like I'm going to write down here, like for example, limit x approaches a of 2, and it's going to be just a 2. Okay, that's a constant. Okay, let's try our properties and do some examples. The first one, it says limit x approaches 2 from the left of f of x plus g of x. So before even I start, what I'm going to do, I will x approaches 2 from the left of f of x first, and then I'm writing properties first. So let's do the properties first. I have limit x approaches 2 from the left of f of x plus limit x approaches 2 from the left of g of x, right? So find the limit x approaches 2 of f of x first. So this is my 2, and this is f of x function, and that's 2. Please make sure that you check this before you start taking limits, because most of the time, if it's different, then your whole answer is going to be wrong. Graph of f of x, and this is 2, and I'm approaching from the left. So this is the left side of 2. And the graph I have on the left that is approaching 2, what is the y value? This is left of 2. The y value is 3. So this is 3 plus limit x approaches 2 of the left of g of x. So this is 2, and that's the g of x, and I'm approaching from the left, which means this is the one I'm talking about, right? So what is the y value for that? 1. You add them together and your answer is 4. So that's pretty easy that way. Okay, let's try limit x approaches 2f of x minus 3g of x. So that one, I'm going to apply my properties first. You know this 2 coefficient? You can keep it outside like that, and you can say, okay, limit. Let me do this in different color. So when we use graph, we know the graph is for that question. Okay. That 2 can stay here outside, and I can say limit, because we don't do anything with that 2, -1 of f of x minus, keep the 3 outside, and I'm going to go limit, because nothing is going to happen to that coefficient, so it's going to stay there. X approaches -1 of g of x. Now 2 is going to stay as a 2, we know that. Limit x approaches f of x of -1. This is your -1. And I'm approaching, this is -1, and I'm approaching from left and right both, because they didn't mention anything. If you guys pay attention, we don't have any signs up on this side, on the right side of this -1. So I'm going to give them both. So I have -1, and I'm approaching from the left. So this is the left of -1, and I started going in this direction, and I'm gonna go where my -1 is approaching. I'm going towards the y value of -1. That would be good. Like, I'm going to the y value of -1. So this is right there, and which is -6. So times -6 minus 3 stays, and then I have limit x approaches -1 of g of x. The g of x, that's -1 right there, and I'm talking about left and right. And this one, I didn't mention this, but here we go, that's from the right. It's still the same. So -1 from the left and right. Okay, this is the left side of -1, and this is the graph that going towards -1 y value, which is -1. And then I'm going from the right side again, it's going to be -1. So that is -1. So -12 minus -3, right? And then we fix this around because this is going to change to positive, and then I have -12 plus 3 will give me -9, and done. Okay, let's do this question. This one is x approaches -3 f of x minus g of x, and -3 f of x. So let's apply the properties first, because I have two functions right there. Whenever you see two functions, adding, subtracting, multiplying, dividing, apply the properties first. Limit x approaches -3 of f of x minus, oh, I should be using different color, right? I should use a different color. Okay, now we're gonna use that dark gray. Okay, so let's see again. Limit x approaches -3 of f of x minus limit x approaches -3 of g of x. And again, -3 left and right, -3 left and right. So I'm gonna apply left and right. Okay, this is -3 right there. This is -3. And I'm approaching from left and right. So this is -3. I'm approaching to the y value of -3 from left and right. Guys, this sentence, like, really working whatever I'm just saying right now. Like, you're approaching, just say it when it doesn't, I mean, you don't understand still, you just say it out loud. Approaching y value of whatever x you have. Like in this case, I have -3. So I'm approaching a y value of -3. And do you see -3 has a hole right there? Which means I'm gonna go arbitrarily close from the left right there. And when I round it up, it's gonna be -2. I'm going from the right, arbitrarily close right there, it's gonna be -2. So this is -2 minus, okay, let's see -3 up here. Oh, we have a vertical asymptote on -3. Okay, so it means it doesn't exist because I don't have any graph here. You see that? And if you check, look what I'm doing. This is the left of -3. So if I approach -3 y value from the left, you know, it's continuously going. There is no y value, which means I'm going positive infinity. And if I pick right side, I'm approaching -3 from the right. The graph is going, and I have these arrows, which means it's continuously going in this direction, which is negative infinity. When you have a positive infinity, negative infinity, which means does not exist. So I'm just gonna write here does not exist. If that's the case, then does not exist. The whole function does not exist, because you can say, and you see, we have to answer that state why. We have to give them a reason, because limit x approaches -3 of f of x is not equal limit x approaches -3 of g of x. So that would be my answer for this. Excuse me. So I don't want to make it a longer video, so I will do the rest of the examples in the next video, and there will be the same graphs, and we will use these graphs again and answer the rest of the questions. Guys, please like my video. Just go through the playlist. You will see whatever subject you need help with. Comment below if you need any help. I can do one-on-one Zoom with you guys if you need it. Subscribe, like. Thank you. Bye.